Well, once again, good morning, good afternoon, or good evening to you all, depending on when you actually are watching this. I'm going to go ahead and get started with 5.1 Day 2 notes. Certainly, once again, if you do have your identity sheet, I would recommend pretty much any time you're working through examples, taking notes, have that handy. So, we'll get started with example 1. These are actually going to be a lot shorter than 5.1 Day 1. There's only a few examples for these, but getting started, secant squared theta minus 1 over secant squared equals sine squared theta. Well, again, anytime you see squareds, one of the first things you ought to look at is, okay, I'm going to be going to my Pythagorean identities, and we can do a substitution here. So, if you look, you can see that secant squared is tangent squared theta plus 1. So that's going to be my first substitution. And again, the nice thing there, that allows us to cancel out the 1's. And so now we have tangent squared over secant squared. Well, from here, what we can do is use a couple of different things. First, for tangent, we're going to use a quotient identity. Tangent squared is sine squared over cosine squared. And then we can actually use a reciprocal for secant. Secant squared is 1 over cosine squared. Now, from here, when you are taking a fraction divided by another fraction, if you remember, our rules of algebra for working with that are we're going to multiply by the reciprocal of the denominator fraction. So, sine squared over cosine squared times cosine squared, and certainly if it helps, leave that 1 in there as a placeholder. And our cosine squareds cancel, leaving us with sine squared equal to sine squared. That was given. All right, next up, 1 over 1 minus sine plus 1 over 1 plus sine equals 2 secant squared theta. Well, for this, anytime you see adding of fractions throughout the identities unit in Chapter 5, pretty much always want to be thinking, okay, we're going to need to get a common denominator. So, for this, our common denominator, I will use 1 plus sine for the first fraction and 1 minus sine for the second fraction. And from there, what that's going to end up giving us is 1 plus sine theta plus 1 minus sine theta all over 1 minus sine of theta times 1 plus sine of theta. Do not cancel anything right now. Because of the addition, nothing will cancel. We can go ahead and combine like terms though. 1 and 1 gives us 2 there, and the sine thetas cancel. So that gives us 2 over. Now, I know yesterday I told you most of the time we are not going to want to actually multiply out our denominators. This is one of those rare instances where we are going to actually have to do that. For one thing, if you notice when we have 1 minus sine and 1 plus sine, the only way to even begin to make that into 2 secant squared theta, we are going to have to distribute our denominator. And when we do, that is a difference of squares, so that's going to give us 1 minus sine squared. And now, our final step here for working with our denominator, again, when we have 1 minus sine squared theta, once again, that's where we're going to use some form of a Pythagorean identity. As I've mentioned, a lot of different ways you can work with this. I always prefer to just use what you're given So I just will use sine squared plus cosine squared equals 1. So in place of the 1, I have sine squared plus cosine squared minus sine squared, which again allows us to now cancel out the sine squareds. We currently have 2 over cosine squared theta, and our final step is, once again, similar to our last example with a reciprocal. We are going to use that 1 over cosine squared is secant squared. So this simply becomes the 2 secant squared theta that we need. All right, final example, tangent plus cotangent equals secant times cosecant. Well, for this, we're going to have eventually 2 fractions that we're going to need to add. So the tangent plus cotangent, we can use our quotient identities. Tangent is sine over cosine. Cotangent is cosine over sine. From here, again, we'll get a common denominator. So I'm going to multiply the first fraction by sine x over sine x. I'll multiply my second fraction by cosine x over cosine x. So that gives us sine squared x plus cosine squared x over sine x cosine x, which now we have the Pythagorean identity in our numerator, so that becomes 1 over sine and cosine. And to finish this one, it needs to equal secant and cosecant. Well, I always like to say 1 over sine is cosecant. Cover up the sine for just a moment. 1 over cosine is secant. So we have 1 over cosine again gives us secant. 1 over sine gives us cosecant. And we now have our third and final example verified for 5.1 day 2. Again, like I told you, these notes are a lot shorter than what we did yesterday.